Okay, so I'm going to show you guys how to use AFrame, and particularly the AFrame inspector, to start building virtual worlds for VR, augmented reality, and XR applications, and also to allow it to run on the web, on a web page, so you've got the best of all worlds, using the AFrame API and its inspectors, and also to be able to do a little bit more than just the basic kind of stuff that you see on AFrame, so, sort of like this low poly logo that you see. So let's get to it. The first thing I want to show you is like AFrame. If you look at an AFrame HTML file, this is a blank HTML file, but if you look at an AFrame HTML file, it basically consists of an A scene with a bunch of parameters. Sometimes it'll have some A assets that get loaded in order to texture things or load objects. And then you have all of these elements or entities that it uses to construct the scene. And you can see that each one of those has a lot of parameters as well. So it can be a little daunting in terms of learning all of these new options for code in HTML. So one way to get around that is to, rather than going and studying the AFrame documentation, which has a lot of good info, we're going to cover some of that, but you can see all of the different primitives that it ships with, and then there's a bunch of modifiers or components that actually add a lot to that as well. So this can be a lot to learn, but you can get into it pretty quickly by just going to the AFrame website and selecting this, and you can select any of these, but I'm selecting this one in particular because it's basically the hello world of AFrame. So when I do that, I get into this little hello world example, and you can see that a couple of things about it. Well, number one, we've got this div, which is HTML loaded on the side. So this shows you can blend this WebGL interface with HTML code. You also have this button, since I'm on a computer, that'll allow you to load, if you have a VR headset, that'll allow you to go into VR and see the split screen version of this. What I want to show you is if you take, from here, you can actually go in and do this visual inspector, which is the AFrame sort of world builder, and allows you to see all of the elements from like a third-person perspective. And you can see and select each one of these elements, and you get a much more sort of user-friendly interface for being able to change the settings. In addition, it'll let you save this stuff or download it to HTML files, so you can make modifications in here and build your scene like you would in a 3D game engine or something, and then just download the HTML and modify that to customize it. I'm going to go back to the scene. Another way to get this, as we did, like you saw here, they had the visual inspector button here. Another way to get into that on any AFrame installation is if you hit Control-Alt-I. It's just built into the AFrame engine. If you hit Control-Alt-I, that'll take you into it. So if you don't see a button, don't worry about it. Just hit Control-Alt-I or Command-Alt-I maybe on the Mac, and that should take you into this. Something to know about this that'll get you around is when I'm rotating it like this, that's just the default left mouse functionality. If I want to zoom in on an object, and this is similar to like Unity and Maya, you just select the object over here and you can hit the F key, and it'll zoom automatically and frame that object, so you're just going to orbit around that. If you want to pan the scene, it's Alt right mouse button. So you're going to want a 3-button mouse for this. And if you want to just zoom in and zoom out, you can use the middle mouse or a mouse wheel. And maybe, yeah, there is no like shift modifier that I can tell to zoom in. Okay, so just the mouse wheel to go in. So let's take this. We want to lose this because it's just taking up real estate, and we can get some more space and work. We're getting a little crunched here. So how can we get this to work from our desktop? So what you can do is, if up here on the left in the scene, kind of overall scene object count window, you can copy this little page indicator clipboard. You can copy the HTML for the entire scene. Copy it. That'll copy everything, the entire web page. Click that and copy it. Go into your text editor. In this case, I'm using Notepad++. Just select or make a new text file and give it something.html, and then paste that code that you just copied from AFrame into this. This is new text area. Oh, probably it's just the builder. So if we go back to scene, we select off and copy this, it'll probably look different. And this may change, actually. They change this every now and then, or at least the functionality seems to break sometimes. Yeah, so see, I lost the text editor, or the text tab when I took it off. So, and that's probably what this canvas tag right here is. It's probably this option or one of these. So the problem is, what I want to do is I want to clean this up. I just want to get the basics so you can see it and make it readable for you and explain what's going on. So we'll get rid of this meta. We'll keep the character set, meta tag. We'll keep the title. Keep the description. The script is going to be wrong. It's loading the AFrame master min.js, but the problem is because we copied this from the AFrame site, you've got these broken link connections, so it's serving it from the web server, and we're not going to have a folder that's going to have this on it. We can fix that real quick in a sec. We'll get rid of this style sheet. That's probably just the font for the page. And then we'll have the body. We've got a scene with a bunch of, and like I said, we're going to lose this canvas tag, but I'm going to keep the canvas tag and show you what it's doing and why we want to get rid of it for now. I'm going to just tab down. And then here are the actual elements for AFrame, the A box, A scene, A plane, etc. All right, so we'll save that. Now, if I'm just going to go back to the AFrame site here. Or actually, I'm going to put it on something that's a little less processor intensive. All right, so because we're rendering WebGL as long as that's open. So now, if I just go to wherever I've saved that HTML file and just double click and load that into the world, notice it's broke. Why is it broke? Because we don't have the AFrame min.js connecting to the right place. So what we can do, since I've gone to the, we'll go to the GitHub. So from the AFrame site, we just click on this AFrame. From the AFrame site, you're going to see a link up here on the right that'll take you to its GitHub page. And then down in that GitHub page, scroll down. Yeah, you'll see examples of AFrame HTML. Usually they use the latest just since it's been edited. But what we're looking for is this script, and notice that the source is web hosted. So it's script HTTPS, and it'll go to aframe.io releases.8.2 AFrame min.js. We're just going to copy that. Go into our Notepad+, replace our script file or our script tag with that, save it, and now we'll go back to our folder, double click. Now we get our AFrame tool, and we don't have all these extra divs and stuff blocking it. So like I said, if we hit Control-Alt-I or Alt-Command-I, that'll take us in the AFrame inspector. Now we have the problem of the div blocking our ability to pan and move the world. Okay, so what we can do to fix that is if we go back to our Notepad+, we'll just delete this canvas. This is the thing. It's basically sitting on top of this world view and blocking our mouse clicks. So if we just delete that and then save the file again, go back to here and then hit Shift refresh. Now we get our tab or our AFrame scene, Control-Alt-I, and now we can actually pan around in the world. So now we have like a working environment to start showing you how this stuff works and how to modify it. Okay, so the first thing is we have some stuff that's sort of hard to see because the background's white. So I want to select the scene, the A scene, and then you'll have this component on it called background. We'll change that to something like a dark gray. I don't want to go black because the grid's black. So now we can actually see these two objects. One of these is the camera, right here. And by camera, I mean that's the camera that is like your starting point, or what your headset is controlling when you come into the world, or your phone, and if you're running this on a iOS or Android device. It will control the camera, and you'll be able to pan and look around the scene with that. But since I'm in the world editor, I'm actually looking at it from a kind of third-person God's eye view. And then so if you want to change the location of your camera, you can just move that around, and it will change where you start in the scene. Then you have these two lights. These two lights actually probably weren't even in the HTML. They automatically get added in case there's not a light in the scene. The reason being that if you don't have light, you won't be able to see anything, so it kind of goes to this default lighting condition if you don't add lights yourself. And I'll show you how that works in a sec. But the lights are an ambient light component, but it's an entity with a light component on it. And I'll show you how the component entity structure works in a sec. And by ambient light, I mean that it's kind of this global light that lights the backside or the shaded or shadowed areas of an object, of all the objects in the world. So it's sort of a fake light. I'll show you how it works. We'll just change the color to something sort of obvious, like a blue. And you notice everything gets tinted blue. That's why I'm not a fan of ambient lights, because they kind of control the overall lighting. You can tone that down a bit, because right now the ambient light's at an intensity of 1, so you can tone it down. You can make the light brighter by going a little lighter on the color. It sort of creates this bluish haze, but it's generally just not a good light solution, because it's sort of it lights too universally, right? We want controlled sort of scenic lighting in this thing. So what you can do to turn off the ambient light is you could just hide it. You notice how everything got really dark. That's because this linear light over here is not set to super bright, because the ambient light sort of balances. They're sort of splitting the lighting. Or you could leave it there and just turn the intensity down. Okay, we'll get rid of it in a second, but I just wanted to show you ways of like controlling the lighting, changing certain things about it. Okay, now we have also this linear light, and by linear, this is like a sunlight. So you see, this is the thing that's actually casting the shadows, and you'll notice that the shadows kind of get a little wonky here depending on the angle of the light. And I want to explain how that works in a second. Whoops. Basically, the shadows themselves are faked, and depending on the way those shadows are set up, they may or may not render correctly. I'll show you how that works in a second. But number one, right now, this light with the ambient light turned off is too dark. There's not enough light in the scene. So if you go select that light, over here in its component, you'll see that the intensity is set to 0.6. You can crank it up to 1, and then you get like full light from that. Okay, so there are other types of lights as well. There is a hemisphere light, which would create like a dome around this. If we do that, you'll notice it goes kind of full color, because there's no shading associated with it. What's going on is that it wants let's see. Yeah, it's just giving an overall, sort of like an ambient light, but I thought you could actually attach a texture to it. It doesn't seem to do that. We'll have to look into that. You can look into the hemisphere lights in the AFrame documentation. I won't go into them for this video. You can make it a point light, which, unlike a linear light, actually can have attenuation and will cause it to fade. So like if you pull it too far away, eventually you're going to run out of let me make this, I'm going to make the plane much bigger so you'll see how that works. So we'll make the plane 100, and the units in this are meters, so real world meters. So you can kind of guesstimate when you're setting up something for AR. You can sort of scale it, knowing that one of these grid squares is a meter. So that means that probably if you're in the world, if you're showing this in AR, this sphere will appear to be about 5 or 6 meters, or maybe 4 or 5 meters tall. So just to let you know, this can apply to real world scale. So you'll see that the now that I've made this plane bigger, the point light casts the shadows out into infinity on the plane. And point light, I took this linear light and made it into a point light. So you can see how the linear light, but it also doesn't light like out forever, right? It only goes for a point, kind of like a campfire. You can change that with this distance modifier. You make it, go out to 100. But it's going to attenuate, so you may go for 1,000. It should get brighter for longer. Oops, 100 may be the max. Yeah, there goes 1,000. So you see it got brighter, and then as you lift it up, what's going on is you kind of have to imagine this thing as a sphere with fall off, like a sphere of influence. So the higher up this thing is, if you imagine a sphere, the bottom of the sphere is narrow, right? And then the top, the equator of the sphere would be really wide. So the higher you move this, it's like you're taking the top of the sphere and moving it up until eventually it gets to the hemisphere, and eventually if you move it far enough away, it will start to decrease again, okay? Hopefully that makes sense. But anyway, just realize that these things have like an area of effect versus the directional light, which goes on forever, right? So you can see the directional light just lights that plane depending on the glancing angle. So if I have it straight at, it's pointing straight at the plane, it's going to light that straight down. And you'll also see that with that, the shadows don't go forever. Like at some point, depending on the angle of the shadow, it gets cropped, and I'll show you why that is in a second. But before I do that, I want to show, and you'll run into the same issue with this next slide I'm going to show you as well, which is the spotlight. So the nice thing about spotlights is they're basically like theater lights, where they have this cone of projection, right? So what you can do with a spotlight is you can change its let's change that distance to 100. So you can see how it sort of attenuated it over the length of the light. We can change the penumbra, which is this edge along the shadow. So if you change that, it's just going to soften it. So you get a soft spot. And the bigger it is, the softer the light. It looks really good. You can have a target on it. So if we wanted to target this sphere with this spotlight so that it tracked it the whole time, same thing with a linear light, we would go to the sphere, give it an ID, we'll call it sphere, and then to target that with this light, in the target just put pound sphere. And notice that the light suddenly locks onto the sphere, and no matter how I move the light now, it's going to be pointing at the sphere. The same thing if this was a linear light. Point lights don't have a target, so a linear and a spotlight will have a target because they can actually point in a direction. The other thing to realize is that this cast shadow, you can make lights that don't cast shadows. And if you do have it casting shadow, you can make objects that don't cast or receive shadows. So if I select the sphere, down below here, there's a component, shadow component. It has to have that shadow component in order to be able to cast a shadow. So if you turn that off, the sphere won't cast shadows, but these other objects do. And if you turn that on and then turn off receive, the sphere will cast shadows, but it won't receive them. So you notice that the shadows are not, from these cubes, are not casting onto the sphere. When I turn that on, they are. And you'll also notice the shadows are really low quality. Like you see how it's kind of fanned out here, or really pixelated. That is just something that happens depending on the light. The soft light from a spotlight, because it casts out in different directions, causes this fading at the edges, just like real light would. But because of the resolution of the light, it's going to be kind of pixelated. So you can change that down here under the shadow map height by making it 1024, and it needs to be powers of 2. Notice that the shadows suddenly got sharper. A little bit sharper, not much. Or you can go 2048. Now they're really hard. But you'll still see they're kind of pixelated. Now that is the shadow quality setting, which is in the scene, I believe. And you can't really get access to it here. So if you go to, try not to get too distracted here, the docs. And let's look up shadow quality or shadows. Probably this. So cast shadow true, that's for the light. Receive, auto update, render single sided. So a scene. So the shadow system exposes scene level properties for configuring the renderer for shadows. These are set in a scene. Example, a scene shadow equals auto update and false. There's another one that has to do with the quality. Basic, that's PCF soft right here. And PCF, so type, so it'd be shadow, auto update false, so then we'd have type. Let's do this, shadow auto update. I'm going to copy this. We'll make that true, and I just want to check. So now if we go to here in our scene right here, keyboard screenshots, we'll just go in the tab of the scene. We're going to add this shadow auto update. We'll make it true. And since it should be a series of options on the shadow attribute right here, we'll just do a semicolon, and then we'll have type, colon, PCF, I think PCF, yeah, soft, one word. And we'll leave that. Save it. But I want, before I save this, since I've made some changes, like I've changed this to a spotlight, I want to show you that you can get the position of the, and we can get these settings that we've got by copying, rather than copying the entire HTML, which we could do. I want to just copy each thing that I've changed. So I'm going to copy the plane, select the plane, and then up here under the on the A-plane object itself in the right, there's another keyboard. So I'm going to copy entity to HTML to clipboard, copy that, go to our text for it and find the A-plane right below that, I'm just going to paste it and compare and make sure that what we're getting is the modified version. So there should be a scale. Yeah, scale 100, 100. So now we can lose this plane. We've got a different plane with a larger scale, and we'll copy the spotlight. Copy the HTML. We just selected it over here and then copied it. And probably going to want to paste, we're going to copy the sphere too since we're targeting that. So we'll go into here, and so you notice, this is what I was telling you, that these were default lights. In this body, when we copied the HTML, there's no light listed in this. There's a box, a sphere, a cylinder, a plane, and that's the end of the A scene. But whereas here you have two more entities, which are the lights. Those get added automatically because there are no lights in this. So if we want to make a light, we just can take what we just copied and paste it in there. And now we have A entity, light, cast shadow type, all of this stuff set. And that will make these other lights disappear when we open it up. I'll show you that in a second. And I want to copy the sphere since I'm targeting that, and we actually gave it an ID. So we'll copy that, go into the HTML, and where the sphere is, just right below it, paste another. Let's make sure it's got the ID, a sphere. Yeah, see ID sphere here. So that way the spotlight can target it because it's got an ID on it. So then we'll delete the sphere. So now if we save this, everything should come in as we've made the modifications. So when we reload, now one thing I didn't copy was I did not, actually it's coming in with extra lights, probably because of the default lighting getting turned on. Let's check. Or it could be the ambient light. Control-Alt-I. Yeah, so we still have the ambient light getting injected into it. You can just turn that off. And actually, it's also got it's still adding these default lights. It's interesting. Not sure if that's a bug or because that's what we had before setting wise. Except for the background. I didn't copy the scene option as well. So we can turn that off or make it gray. Trying to figure out why the other lights came in. Again, I think let me look. Let's try this. We're going to add an entity. I'm going to show you how to add something just totally new to the scene. So we'll add an entity. Right now, when you add that, it's basically this comes in and it's all blank. There's nothing. It's just an empty object, which is cool because you can use this as like a grouping. You can move these under that and make them grouped if you wanted to, and then you can move whole sets of objects. You want to give this an ID. We're going to call this Spotlight. Then to make it a light, we will go click on the add component here and scroll down to light. So notice that as soon as I did that, all my other lights disappeared. Okay, that's just something that happens in the inspector now. Now maybe it's because I added the other lights. I just modified a light, it kept the others. Something about, I don't know. We'll see if this sticks. But so here's our spotlight. Well, right now it's a directional light. Change it to a spot. And change the penumbra. We want it to cast shadow. We'll change the penumbra. Pull back. We can change the spot angle, widen it and shorten it, open it up some. And we're going to give it a target. So we'll say sphere, pound. Now it's targeting the sphere. And I think that's good. We'll save. Actually, look at that. It's actually softer on the shadows too, which is interesting. So maybe it already has the PC. Oh, because that's showing you that the PCS soft actually worked, the setting that I had in the HTML. So let's see if we can get this to stick. I'm not going to copy everything here. I'm not going to copy, I'm not going to copy the individual. I'm just going to copy the entire HTML and paste over what I had. So we're going to copy this up in the left, go into our HTML. I'm going to make it a little bit smaller so I can see what happens as I paste it. Paste over everything. So notice that because I'd already targeted the right min.js, I'm still targeting it there. And everything else comes in correctly except I've got my canvas back because I was in the inspector, so I can just delete that. Here's our spotlight. Here's our PCF soft setting on the shadow. And we'll save that. Hopefully this should now save everything so that when I shift reload, it comes in accurately. Yep, sort of accurately. It's like the position on the spot didn't change. It's low, but you can see that the lighting's right. Let's see. Control-Alt-I. So somehow, here's our spotlight. So we didn't get the other lights, which is good. Yeah, somehow the spot, just for whatever reason, the position was low. But it is targeting the sphere. So we'll copy, so copy the HTML and go to our text. I'm going to just replace, actually let's don't replace, let's make sure. So the issue is this. The reason that it didn't when I opened this scene in the first place is that it doesn't have a transform node on it in the HTML. So like if you look at the entity, it says light, type, spot, all of that, but there's no positional data on this entity like there is here, okay? So if I want to get that, let me see if I can copy. Actually, let's try copying again, because sometimes I've noticed that some things just don't update. Yeah, there's no position. So let's put a position right here on the entity. Actually, I've also got that below the A scene. Let me put that there. So right here at the end of the entity or anywhere after, you can even put it here before the ID if you want, and put a space there. So now we just need to copy the settings. So it's X, Y, Z. So the X will be, I'm just going to do it roughly, -3.25. The Y is 5.2. And the Z is 3.455. I'm just going to do 3.45. We'll get rid of this light, which is outside of the A scene. We'll save. Go back. Oops. To the reload, shift reload. Now we get the way we wanted it set up. Let's say we've got a sharp spot on the front, kind of like a stage, and we want to turn that and make like something else where it's backlit, so we get like, or a top lit, kind of like an actual 3-point stage light or a movie light. So if we take this, we can actually copy it or clone it. Notice to the right of it, you've got this little duplicate. We can clone the object. So now we have two spots, and they're both targeting the sphere, because I just made a copy of the one. So the one's called Spotlight 2. And we can take that and move it, something like that, and move it up high. and also tone it down. So we'll take the intensity and make it something like 0.3 and give it a yellowish color. I'm going with like a typical 3-point lighting here. So you notice that the color actually colors the scene as well in the highlight of the light, but it'll also sort of give it this yellowish backlight. And you may want it to be more glancing, depending on the material quality. So if you got that, then you may also want a blue light coming from the other side. So we'll clone this. So now we have 3 spots, and I'm going to make this one light blue. And make sure so it took the original setting. So here's our light blue. Actually, light blue probably would be coming from, I just want to get it backlit. So we can change the view angle on that, so we'll make it like 60. Open it up. Same thing for our yellow. Since they'll be wider, kind of more area lights. So then you start to get sort of a stage lighting effect with shadows cast different directions. Let's see what that looks like in the scene. Yeah. Okay. Now we may want to play with, I'm going to actually keep those spots. Let's go back. I'm going to lose the spots for now. I'm going to delete those. I want to just go back to by deleting, I'm just clicking on the trash can next to the object. I'm going to change this back to directional. So I get an all over light. I want to show you how to create like a background for this, a skybox. So to do that, we're going to need to have a texture. We could do it with just a color like what we have, but I want to put an image in there, a hemisphere image. So in order to do that, let me go ahead and copy everything here. Copy, go into our HTML, paste, lose the canvas so I can actually edit it right there. Make sure, position wise. Oh, it's still called Spotlight, but that's okay. All right, and save, and we'll refresh. Let's see, make sure everything took. Yeah. All right, so now we have our scene to edit. I want to add a skybox or a sky. So if we go to AFrame and search for sky or a sky right here, you'll find that it takes this a sky primitive, but it's looking for a source, and the source will be an image that we load, and this brings us into how to load images. So we're going to look at this a assets tag. So if you copy that and go to your HTML, you want to paste that right after the scene. It'll be the first thing you load in the scene because you want to start the assets loading as you go in the very first thing. And for assets, you can load objects, you can load images, you can load sounds. All this is just creating an asynchronous loader. So what we're loading here is an image, and we want to give it an ID so we can target that in the a sky element and make it the background. So what we'll do is I've gone and downloaded, if you want to do a sky background, you're going to want to look up like equirectangular. and it's a type of image that just wraps around a sphere. But the way to find them is just look up equirectangular in Google, look for the images. You may want to look like for something that's a power of 2, so something like 2048 by 1024. So to do that, you just select Tools, Size, Exactly, and they're 2 wide by 1, so it'd be 2048 by 1024. You can go bigger than this too. And then that's going to find you a bunch of images that will be as big, the size that you need. You could also go 4096 by 2048, but then you're starting to get into a really big image. We'll talk about how to work around areas or issues of resolution, because these things will start to get blurry. I've gone and copied this image to my hard drive already. We'll close this, and I just need to find where. Let's see, put that, I accidentally opened Photoshop. It's not going to be good. We'll close it down in a sec. Anyway, I've put these textures, and we'll close Photoshop. All right. So in the textures, down here, I have this sky.jpg. So all I have to do to target this to load it is to basically change this source in our assets to /textures/sky, and instead of a PNG, it's going to be a JPEG. That should hit it. All right, we'll save that. The other thing is I want to put a sky in here, so we'll go back to our HTML and the A-sky, and we're just going to take this A-sky and source right here. And I'm going to show you how this gets made. All A-sky is doing is basically creating a sphere with a certain type of material on it that's inverted and putting this texture on, as a texture on the sphere. And we'll see that in a sec. So I'm just going to put the A-sky right here. Save. And if we go to Hello World and refresh, notice that it didn't load. Why didn't the sky load? Now it's dark, and if you go to Control-Alt-I, you'll see that we have an entity right here called A-sky. And all that is just a geometry, a sphere, and a material that is set to render flat. And then down under the material, there's the sky that we've targeted with loading our texture. So everything should be working, but it's not showing up here. The reason for that is if you look under, if you're on a developer, if you've got developer tools set up on your browser, you can go to developer tools and get the console and see that it's complaining up here, the AFrame error, about loading it from the file, having access. So basically, browsers will not load text or files from your hard drive if you're doing development. They won't load on the fly. You're going to have to host them somehow, run it through a Node.js server locally, and hit that. I believe AFrame may actually even mention something like that. Yeah, you can look it up. There's talk about how to do it, and it even gives you a link to that. But the other thing you can do is you can disable the CORS functionality, the cross-origin functionality, the thing it was complaining about on your browser. I suggest you not do that, because that will open up your machine to downloading stuff and executing things. That'll probably be a security issue for you. But in my case, I actually have a browser that I've enabled for this purpose that I don't use for anything except for local testing. So if I right-click on this blank HTML, which is this file in the browser, if I right-click on it and open it with Firefox, where I have disabled my CORS, then it will load, and I get my background. Okay? So we have this cool background now with our equirectangular image. Okay, that's how you get a background into it, the A-sky. Now, what about metallic objects? What if I want to make the sphere reflect the sky, or appear to reflect the sky? How do I do that? So the default material on this sphere is basically just a color, but it has this material called the standard material that allows you to do a lot more than just that. For one thing, you can make it metallic, so you can crank up the metallic quality. So metals are super reflective and shining. So by cranking the metallic all the way up to 1, it makes the specular point, and then the color goes dark because metals only get their color from reflection. The other thing is the roughness. So I can make it super mirror-like by taking the roughness down to 0. So this is what a metallic object with nothing to reflect, a mirror basically, would reflect black, right? If I take the roughness up, then it goes and it loses its specular, but it's still metallic. It has this weird sort of plastic look. I'm not even sure what you'd call that, but a matte metal maybe. So now what we want is we want to be able to simulate the reflection of the environment, the sky that I've put in there in this. So the way you do that is there's 2 ways to do it. There's an environment map, which is this. What that wants is a list of square objects, a cube map. If you go to a sky and if you look up environment, material environment maps, this is what you would load in the scene. It would be a bunch of images, a right side, a left side, a top side, bottom, front, and back for a cube map. And how would you create a cube map? You could take that equirectangular image we've done and go, let's look at Google equirectangular to skybox convert. You'll find a bunch of things on the web that allow you to do it. So like this one, I'll show you what a skybox looks like if we get there. So this would be a typical skybox. What we would want is these separate images. So you just would select that. You'd choose, so we're converting a cube map to equirectangular. We would want equirectangular to cube map. So you'd select your sky object that we loaded, and just select this and export these individual projections from it, these cubes, and then you'd load those using in this format, and then use that as your environment map for your sky material. What is the advantage of this over just doing the single image? The disadvantage is obviously you have to load multiple images. The advantage is that limit that you might run into of 4096 size on your textures, you wouldn't have that same limit using this, because each one of these textures could be 4096, and in that case you'd get 6 textures times that. So the quality of the sky map would be much higher. The problem is that's going to take a while to load. So I just choose instead to stick with, especially since it's a reflection, you can actually go a lower quality on a reflection because you don't need as much. So I'm just going to take the exact same sky that we're already loading and applying to the environment, and use this spherical environment map as the reflection for it. And to do that, you just hit sky, and that should do it. So it won't save just yet, but all I have to do is copy. Let's copy the sphere and go to our HTML. Find the sphere here. So now we should get a material node when I paste this. So we have metalness, because we've changed that, roughness, spherical environment map, but notice that spherical environment map comes in as object HTML element. So you just change that to pound sky. And you'll also look at the sky plane here. That's set for pound sky, because there's no material. It's the sky automatically knows to apply this to the material. It's building it on the fly. And that should do it. Save that and reload. So again, I'm getting black because I'm doing it on Chrome, and you're going to want to load this in a CORS disabled browser or host it. I suggest hosting it unless you want to have a development browser like I do. So I'm going to load this. Now you see we have a nice metallic sphere. Okay. I'm running two different versions of this, so I'm going to close this one to save myself some processing. Whoops. Go here. Yeah, it's smoother now. It's because I was running two versions of AFrame and recording this. All right, so let's play with, let's go full screen. How do I, let's look at the properties for the metallic. So we'll go Control-Alt-I in Firefox. And we'll zoom in on our sphere. Oh, I've got two spheres. Hold on. I must have forgot to delete the one. Let's go to, yeah, I didn't delete the one. We'll lose this one. Save. And go to, right click. I'm going to open with Firefox. So in order to get this CORS disabled in Firefox, you're going to have to, you have to go and you can look it up, but there's ways to do it. I'm not going to tell you how because I don't want to be responsible if you have somebody that injects something onto your machine by doing it. But so here's our sphere that's metal, right? Notice that by moving it, it's changing the shadows. That's because, again, I'm targeting the sphere with the light. So when I move this sphere, it's actually making the light direction change too. So if we take the sphere and we want to make it, let's look at the metal qualities. So if we turn off metalness, notice that it becomes more plastic-like. It still has the reflection, right? Sort of like shiny plastic. But it's lost its metal quality, and that's just the way the renderer works. So if we want to make it more matte plastic, kind of a diffuse plastic, it's still got the reflection barely there, but it doesn't show up. Now if we take and crank up the metalness, notice that by cranking the roughness or changing the roughness, it actually is sort of like making it like brushed aluminum. So it changes that. You can go up like higher. So if you wanted to make a gold ball, you just would change the color. And probably go less or darker. So you don't want to be too saturated or dark on a metal. Okay, whoop, I just disabled it. Looks like a Christmas ball right now, but all right, so there's the gold, and then if you wanted to make it less diffuse or sharper, so there's like a mirror, and then you can just blur it up. So you can kind of tell if we're blurring it here, that the quality of the map for the reflection doesn't need to be as high. It can be much lower, and that may save you some render frame, frames rendered or some FPS on the rendering. But we'll leave it like this for now. The other thing you'll notice is that the material shifts. That reflection map is located to the object. If the object moves relative to the map, then it changes. But if you're panning around the scene like this, you get the same reflection map. So the reflection map's kind of locked to the camera. If we go back to the scene and walk around, notice that as you look at the map, it's constant. And it may be that the environment map with the cube mapping, it won't do that. I'm not sure. I don't want to load one right now to check, but that's something to play with. So it's not a super realistic reflection in terms, because it should be reflecting what's going on back here and be locked, right? And I don't know of a setting that you can adjust to make that work. Okay, so normally that's not too big of a problem, because usually you're not getting like a super reflected metal where you can actually see that it's not changing. Usually it's pretty subtle, and you'll use an object or some sort of diffuse roughness map or something, so you barely get any. So like, just to give you an example of that for the roughness, let's go back to, I'm going to close this. I'll lose my gold setting, but I want to close this, and I want to load one of these textures, or actually a couple of these textures. I'm going to load, real quick, these are some textures that I used on another object. I just want to try them out on this, and I'm looking for a metallic, this door. I'm going to set, this is a color map, this is a metallic, actually that's the pedestal, sorry. Just got to find the right, here we go. So this is a color map, a metallic map, a normal map, and one of these is a roughness map right here. Okay, I'm going to load those, so we'll copy the name, and I'm going to put them in this assets and load them. Image, ID, we'll call it door _C for color, source equals ./textures/ and I'm going to paste that. So there's my base color map. I'm just going to copy that 4 times. And I'm going to make a normal map for the bump, a metallic map for the, let me zoom in here, a metallic map for the door, or for the metal, and then a roughness map for the roughness. And all I've got to do is just change the names here. So like this will be, instead of base color, it should be normal. This one should be metallic. Yep, 2 L's. And roughness. So the reason that I gave them these IDs is so I could target them in the material. Okay, so we'll save that. And rather than go and like add those nodes to the, to the sphere, or the whichever, the sphere, I'm going to load this back up in, let me go back out. I'm going to load this in Firefox. Go into my inspector, select the sphere. Do I want to do the sphere? Yeah, we'll do the sphere. Why not? Here. And then I'm just going to target those maps on the appropriate node. So for metallic, or the metalness map, I'm just going to do pound door _M. So that loaded that. Let me zoom in on this. I'll select the sphere, hit F. There we go. So you can see by making that metalness map, suddenly now I've got this map associated with the sphere, and like some of it's reflective and some of it's not. Okay, that's the metalness map. It's a grayscale map. I'm going to add a bump, which will be the door _N for norm. So notice that I just got like this specular bump associated with it. And you can change the scale of that bump so that it looks different. Let me zoom in on this box. I might be able to get closer that way. So F, yeah. So that lets me get closer and see this thing. So you can I can tell by the look of it, because where the light's coming from, that the lighting's not quite right because of the way the normal's popping. So if you go normal, you can change, it's not updating though. It's interesting because it doesn't seem to update the normal map. If I recall, something like 3 on the .3 and a -4. We'll see what that looks like when I load it back up. Now we want the roughness, so it'll be door, pound door, _R, and that should do it. So one thing, I want the color, and I want the source, so that'll be pound, door, _C. So now I need to lose the, I'm doing it on the wrong object. I'm doing it on the cube. Want to do it on the sphere. That's why it wasn't updating. So when I changed the normal scale, you can see how it shifts. So I want to be negative and just be less dense. Maybe it's, yeah. Something like that. It starts to look right there. Okay, so I had it the wrong way around. It was -3 here and then positive like that. But you can play around with that. It just makes it go in and out, shift in and out. Okay, so now we have door R, door color. And let's see if we get that when we take this and make it white, because right now we want to lose. Yeah, we want to get our color from the map. So it's white right now. Notice that door C, there we go. Got our color that way, and then we need our roughness. I just needed to enter it again. Door, even though it shows up, sometimes it doesn't stick. There's our roughness. And make sure we got our normal. Well, it's on there, obviously. So, and then we got our door metallic. So now if we crank the metallic down a little bit, it's very plastic. So we want the metallic up, and we want the roughness to be full control from the map. So by cranking these down or up, it basically says how much the map controls that function. If we take it halfway, then it's half map, half universal, okay? But we want it, because these maps are set up correctly, we want it to be controlled by the full metal qualities of the metal map, and we want it to be controlled by the full metal roughness qualities of the roughness maps. And what happens then is you start to see that we get a much more realistic object that has metal where you expect metal, and then a little bit of rough from the patina and stuff like that. Okay, and all this is just the normals from the way the map was created. The map doesn't cover the entire object, but you could actually make that work just by scaling probably each one of these texture offsets in scale. You'd have to make them match though. Yeah, texture repeat. So, well, I won't go in. Well, actually, let me just change that real quick. So, you've got this metal texture offset, metal texture repeat. So maybe we want to make it instead and get rid of that top. So we might make it like point. Actually, we want one on the X, on the U, and then we'll make the V, which would be the Y, be like 0.5. And let's do that for the normal as well. And the roughness, and the color. See, the color doesn't seem to have. Here's the repeat, 0.5. It's not updating though. Am I on the wrong thing again? Nope, I'm on the sphere. These actually don't seem to be changing anything. Maybe it'll update when we change it, so let's leave it at 0. With the repeats set, let me just make sure I'm not missing something. Alright, so we'll copy this entire object now. Copy. Go into our texture, or our file, and replace the sphere. We're just going to put one below again and make sure we're getting everything. So notice that all of my maps were off when I copied it from the browser. I don't know why it does that, but all you have to do is go back and replace them. So this is environment, so that'd be pound sky. Metalness be pound door underscore M. Normal door underscore in, and so we got our normal scale, which is good, and then we have our source, which would be door underscore color. I don't know why they don't call it color door or pound door. C, roughness pound door underscore R. And yeah, so it even took all of the repeats. That's good. Roughness, yeah. All right. Now we'll lose this sphere. And save. So then, let's see what happens if it updates. Yeah, so it did. You notice that I lost the... by changing the repeat, for whatever reason, it doesn't update on the object, but it does update, or in the inspector, but it does update after you've loaded it. So let me look at the box. F. Yeah, so see it pinched it, brought it up. It's one way to solve that solution, but usually you're going to have objects that have the proper material setting or the proper UVs set up. Doesn't look too bad though. It's pretty good. So that's how you get more realistic materials, is using these diffuse normal maps, etc. Let me just show you what those look like real quick before we go up close. Right here. So the door, there's the color for the door. It's just a albedo map. There's our metallic map. So if you look at it, the white is obviously metallic, the black blocks, and it's going to be less metallic. There's the normal map, and then there's the roughness map. Okay, so hopefully that gives you a good idea about how to make more realistic scenes in AFrame.